So for 6.2, the important thing here is um, summarized at the end. So make sure you always go to the summary pages. You'll need to replicate your special triangles, but this time with radians. You'll need to understand a unit circle. That's a circle with a radius of 1. You'll need to understand how y and x relate in that circle to cosine, tangent, and sine, as well as cosecant, secant, and cotangent, which are just the flips. Cosecant's just the flip of sine. Secant's the flip of cosine, and cotangent's the flip of tan, but how you would find it given x and y values or r values. And the cast, remember the cast. Now, generally speaking, in trigonometry, you're always going to have two possible answers. Let's just pull up Desmos. Let's pull up a sine curve. And let's make that sine curve limited to 1 revolution. There we go. That's the sine curve. Now, if I put any random y within that sine curve, I want you to notice something. So this y would represent the sine value. But I want you to notice that that y passes through the sine curve twice. That means there's always going to be two possible sine values, or two possible answers for most trigonometric functions. So minus 0.5, you'll see the same thing. It goes through the sine curve twice. So two possible answers where sine is minus 0.5 is 7 pi over 6 and 11 pi over 6. So you can see there's almost always two possible answers with two exceptions. When y is 0, there are three answers. When at 0 degrees, at pi degrees, and at 2 pi, sine will be 0. And then at the peak, there's only going to be one answer. Sine can only be 1 at pi over 2, and it can only be minus 1 at 3 pi over 2. But generally speaking, you're always going to have two possible answers, and that's also if you re-examine your cast rule. Your cast rule says cosine is positive in quadrant 4. All of them are positive in quadrant 1. Sine's positive in quadrant 2. And tangent's positive in quadrant 3. Which shows you if you're talking about tangent, for instance, tangent is positive in both these quadrants. If you're talking about cosine is positive in both these quadrants. If you're talking about sine is positive in both these quadrants, which is why there's always two answers. And we're always going to be working with the acute angle, which is found in quadrant 1. And it's always against the x-axis. For instance, if you need to determine the sine for pi over 3, you are also talking about when sine is positive for pi over 3, you're also talking over here, which is pi minus pi over 3, which is 2 pi over 3, 2 pi over 3. So both these angles, 2 pi over 3 and pi over 3, will have the same positive sine answer. If you're not sure, or want to confirm, go to your trigonometry. Make sure, by the way, instead of degrees, you're in radians. And you'll discover if I do pi divided by 3 and press sine, I'm going to get a value of 0.86666. And if you do pi of, or 2 pi divided by 3 and press sine, you're going to get the same answer, 0.8666. Both are positive. Now be aware there's also a pi over 3 over here, which is the acute angle here, but we'd have to measure all the way around. So it's 2 pi minus that, and 2 pi minus that is 5 pi over 6, or sorry, 11 pi over 6. Oh wait, pi over 3, sorry. 5 pi over 3. And it's also over here, pi plus pi over 3, which is 4 pi over 3. However, when I punch these acute angles into the calculator, notice which quadrants we're in, C and T. While I'll get the same numerical value, my sign will now be negative. 5 times pi over 3 press sine. I get the same numerical value, but this time it's negative. If I do 4 times pi over 3 and press sine, I get the same numerical value, but it's negative. So there's actually 4 angles that'll have pi over 3. 2 of them are positive, 2 of them are negative. All right, let's get to the questions. Oh, always be able to reproduce your special triangles. I think I have a video on it. It's not hard. For each trigonometric ratio, use a sketch to determine which quadrant the terminal arm of the principal angle lies and the value of the related acute angle. So that's good practice there of what we were just discussing. So it always helps to draw your Cartesian graph. So where is 3/4 pi? Well, pi would be 90 degrees, so 3/4 must be less. Pi over 2 is 90 degrees, and pi is 180. So 3/4 must fall in here somewhere. So that means this particular terminal arm falls in quadrant 2. And if you look at the distance between 3/4 pi and pi, it's 1/4 pi, which means we're talking about the acute angle, pi over 4. That's because if I were to add pi over 4 to 3/4 pi, I reach pi. And it's always about the angle formed with the x-axis, not the y-axis. So that means pi over 4 for sine will give me the same value as 3/4 pi. And let's see, what else do they ask? So use a sketch, terminal arm, the value of the related, and the sign of the ratio, and the sign, so whether it'll come out positive or not. Okay, it's going to be, since we're talking about sine, this is C-A-S-T. This is in the sign, and this is sine. They're both positive, so the answer will be positive. Okay, what about the next one? It helps if you map out your Cartesian with the 4 major spots. 270 degrees and 380, and 180 is pi, and 90 is pi over 2. Where does this fall? Well, 5 over 3 as a fraction is bigger than 1. So that means we're past this. The question is, does it fall in this quadrant or this quadrant? Well, let's look at this. Pi over 3, let's put that back. 5 pi over 3 is the same as pi plus 2/3 pi. 2/3 pi is past a half, which means I'm over past here and into here. The distance between pi and 2 pi is 1 pi, and 2/3 falls roughly in here. So let's look at where that would be. That's here. If you want to look at it another way, this is 1.5. This is 1 2/3. 1 2/3 is bigger than 1.5. So that means we're talking about this quadrant, and we're talking about the acute angle. 5 over 3 to distance to here is 2 pi over 3. So that means we're talking about 2 pi over 3. Pi over 3 is 30 degrees, so twice that is not. Pi over 3 is, pi over 6 is 30 degrees. Yeah, so 2/3, I've drawn it incorrectly. 2/3 is more like up here. Actually, you know what? 2/3. 1.5 is pi and a half. This is 5/3. There's only a third left. Sorry, a third. The acute angle is pi over 3, which is, by the way, pi over 3, pi over 6 is 60 degrees, which means that here is the same as 300 degrees. So if you know your special triangle for 60, you could figure out the exact values. But anyway, for cosine, this is positive here and negative for the acute angle. No, positive, sorry, because it's all over there. All right, what about 4 over 3? Tan 4 over 3. Well, tan is the same as 4 over 3, rather, is the same as 1 and a third. A third is less than half. Here's 1, and a third would be here. So that means since this is 1 pi plus a third, this is the terminal angle, 4 pi over 3. But since it's 1 and a third, we're talking about the acute angle, pi over 3 again. So you could use your special triangles and figure out all the answers. Now, according to cast, it's positive here. Oh, sorry, that's not cosine. Tangent. Positive. Tangent's positive here, and tangent's positive here. So the sine will be positive. Now, remember that secant is the opposite of cosine. So let's figure out where it is. First, 5, 6 is almost. So remember when we had, 5, 6 is almost a complete. Let's just get rid of the other one. There we go. Get rid of this one too. So where is secant? Secant's the opposite of cosine. 5, 6 is almost 1. So going all the way here. And how much would I have to add to this to make 1? 1 6. So we're talking about the acute angle pi over 6, which is 30 degrees. And 5 pi over 6. Now, secant is going to have the same sign as cosine. If I look C-A-S-T, cosine is negative here and positive there. You're going to have a negative value. And you can always punch it in your calculator to make sure. And now to the next one, cosine of 2/3. 2/3 is almost 1 again. It's 1/3 short. It's past a half because 1.5 would be half. So it's over here somewhere. That's 2 pi over 3. If I look at how much more it would take to get to the pi, it would be 1/3. So we're talking about the acute angle, pi over 3, which is 60 degrees. So you can use your special triangle. And we're talking about cosine here. So according to cosine, C-A-S, only sine would be positive. So the cosine of the principal angle is negative, but the acute angle is always positive. And the last one, cotangent's the opposite of tangent. 7 over 4 pi is the same as 4 3/4. 3/4 is past a half, so there's 1. There's 2. It's in here. So if you look at how much more to get to 2 pi, it's 1/4. So this whole way around, that's the principal, is 7 pi over 4. But if I look, the last little bit's 1/4. So we're talking about 45 degrees, pi over 4. So that means since this is cotangent, and this is in quadrant C, it's negative down here. The value is going to be negative, but it's going to be positive. The acute angles are always positive. I think that's what they were asking for. Even though all of these fit within the special triangle, you could have figured out the exact values. They want to sketch each angle, determine the value of R. Okay. Determine the primary tributary ratios, and calculate the radian. Okay. That's not too hard. Okay, this one's also good practice. Number 2. Sketch each angle. Determine the value of R, that's the radius length. Determine the primary trigonomic ratios. Calculate the radian value of to the nearest hundredth, which means you use a calculator. Whenever you see this, if it says exact, you can know you're using your triangle, your key triangles. If it says nearest hundredth, you're using a calculator. So what quadrant is 6, 8 in as far as x goes? Well, x is positive and 8 is positive, so it's here. What quadrant is minus 12, minus 5 in? Well, x is negative and y is negative, so it's here. What quadrant is positive 4x minus 3y? Well, positive 4x is here, but minus 3 is down here, so it's here. And what is 0, 5 in? Well, 0x is here and 5 is here, so it's right on the y-axis. Let us start with 6, 8. Just draw a big circle. Put the center of the circle at 0, 0. And 6, 8 will, of course, be little 6, big 8. So it's going to be 10 to be like here, 6, 8. Now draw a triangle. First draw the radius arm. straight to here. Then draw a triangle, green length down if you want, straight down, so it forms a right angle triangle, and blue length across x-axis. Since 6 is the x value, we know that the length of this blue triangle is 6. Since 8 is the y value, we know that this green line is 8. To figure out any Pythagoras or any hypotenuse, you do 8 squared, 64, plus 6 squared, 36, which is 100. And then this will be the square root of 100, which is 10. So that means our r is 10, which means we've already figured it out. Now they want this, they're calling this the angle. So we'll call that the angle theta. And we now know the opposite of the angle theta. I'll just make this black and smaller. The opposite is 8. The adjacent is 6. And the hypotenuse is 10. Which, if we're talking about the sine of theta going back to our SOHCAHTOA, is opposite over adjacent. Well, we know the opposite's 8, the adjacent's 6, so it's 8 over 6. But we simplify 4 over 3. That means the sine of theta is that. Means the cosine, by the way, now that means the cosecant, which is the opposite, is we just flip it. Cosecant of, we'll call it theta. Which means the cosine of theta is the adjacent over the hypotenuse. Oh, sorry, sine is, sorry, I made a key mistake. Sine is opposite over hypotenuse, which is 4 over 5, which means this is 5 over 4. Cosine of theta is the adjacent over the hypotenuse, which is 6 over 10, which simplifies to 3 over 10, which means the secant of theta is equal to 10 over 3. Oh, sorry, that should be 5. 5 over 3. Moving on, the cotangent is opposite over adjacent, or sorry, the tangent, geez, I'm all over the map, opposite over adjacent, which is 8 over 6. That one's the one that's 4 over 3, which means the cotangent of theta is 3 over 4. Those are all your values for all 6 primary trigonomic functions. The radius r is 10. Calculate the radial value. Okay, so you can take any of these and you'll get the correct theta, no matter which one you take. So let's take 4 over 5. Let's take 4 divided by 5, which is the cosine of theta, and we're going to do the anti or arc cosine, or arc sine rather. And that tells me that this value, I'm going to try that again, 4 divided by 5 is equal to that. And we're going to go theta second, sorry, I did it wrong, sine, there we go. That tells me this angle theta for part A is this value. Now what's interesting is I can take any of these sine, or any of these values down here, and I will get the same answer. So for instance, if I take 5 divided by 4 and go to my trig functions and hit the arc cosecant, I will get the same angle. If I go down to cosine 3 over 5 and hit the arc cosine, I will get the same value. Over and over again, it doesn't matter which one of these you use, they all should reveal that it's 53.13. And since we're nearest hundredth, we just cut off here. It's 53.13. And you might say, well, what if they want it in radians? And it's a good point. 53.13 divided by 180, and throw the word pi in front. If you cannot adjust or simplify that more, or don't want to, this is a perfectly legitimate answer. There you go. That's in pi radians. Moving on, it's the same thing over and over again. Let's try to just get rid of everything here. Where's this point? Minus 12 minus 5 is down here. It's more negative x than y, so it's around there. And it's the same thing. Now you can keep your values as marked as negative, and that'll work as well. Notice that my x is negative 12. And my y is negative 5, which means my hypotenuse will be the square of 5, which is 25, plus the square of 12, which is 14, and which is 144. And if I take the square root of that, I'm going to get 13. Notice my hypotenuse is always positive. That's because it's the result of two squares. It's the sum of two squares. But that means I can figure out all my values. So that means the sine of theta is equal to the opposite, minus 5 over 13. Notice that it gives me the correct sign by keeping x and y in their proper things, which means the cosecant of theta is negative 13 over 5, which means the cosine of theta is equal to the adjacent over the hypotenuse, which means the secant of theta is equal to the flip of that. Put the minus on the numerator always, which means the tangent is opposite over adjacent, which will become positive. This is why tangent in this quadrant is positive, because you get the division of two negative numbers. It makes it positive. And that helps you understand why these cast exist, which cotangent is equal to that. Now the nice thing again, I can take any of those values. This time I'm just going to take one. I'm going to take the tangent, 5 divided by 12. And I'm going to do arctan. And I get this. But again, it doesn't matter which, and now they want it to the 100th degree, so that rounds up to 2 degrees. Now it doesn't matter which one I take. Just to prove it, I'm going to take the secant here, which is minus 13 divided by 12. And I'm going to take the arcsecant. And I get, oh, sorry, that's not right. So cosine is that, which means this, oh, that should be, yeah, secant. So make sure I got my cosine correct, 12 over 13, yep. So I'm going to take 13, I think I forgot to make it negative. I'm going to make it 12 divided by 12, and I'm going to take the arcsecant. Still got it wrong. Oh, because it's giving me that quadrant. So if I subtract 80 from it, or 180 rather, I'll get the correct angle. I forgot that it's giving me the primary. The only time it can't reach negative in the acute area, can't reach negative over here, so it has to go all the way over here to the principal angle. So it's giving me the principal angle. And actually, you know what? That's my mistake. This 22.62 is the acute angle. I have to add 180. So the actual angle is 202.62. And that was proven when I had to use one of the negative numbers. It had to give me the proper value for that. So 12 over 13 negative is arctan, arc cosine rather. Yeah, it's giving me 157. Why? Oh, it's giving me the earliest acute angle over here. That's right. Okay. Still works. Because when you do a calculator, it's going to give you the first angle of the principal. So it's giving you this one, which also has a negative cosine. So actually I should use the sine, because that's the only one that's going to give me the exact principal angle, because that's the first time that sine is negative. So I'm going to do 5 divided by 13. Make it negative. And if I hit arc sine, oh, it's just giving me the negative value over. It's giving me this negative value over here, which is the same thing. But since we're in this quadrant, and I know the acute angle is 22, I have to take 180 and add it. So that is indeed the principal angle, if they are asking the radian value of theta. Depends if they're asking the acute or the principal. So the acute is 22.62, but the principal is 202.62. And since this was in quadrant 1, both the acute and the principal worked out to be the same. Okay, let's keep going. This next one is a positive x but a negative y, so it's going to be down here. Right there. Get rid of this one. If you draw a triangle, we discover it like this, where the x value is 4 The y value is -3. The square of -3 is 9. Square of 4 is 16. So I get 25. Square root of 25 is 5. So that means the radius is 5. If I go through them all, sine is equal to opposite over the hypotenuse. And cosecant is equal to the flip of that. Notice that sine and cosecant are negative. Cosine is equal to the adjacent over the hypotenuse. Notice it's positive, which means secant is equal to the flip. Tan is equal to opposite over adjacent, which means the cotan is equal to the flip. Notice that everything is negative except for the cosine and secant because we're in quadrant 4. Now, I'm going to use the positive value of cosine to discover the acute angle. So I take 4 over 5, and I take the arc cosine, and I get this acute angle of 36. But notice we're in this quadrant, so that's the acute angle there. But I have to subtract that from 360 to get the principal angle. And in 2 degrees, it's this one, or 100th degree. So it's that many degrees is the principal, and it's going all the way to there. That's the principal. You could also say it's negative 36.87 if you wanted, because that's still a correct principal. And then finally, the last one is sort of tricky because it would exist here at the top of the circle. And here you just have to trust your knowledge of cos, or this will always be cos comma sine, which means this is going to be the sine. If you look at the hypotenuse doesn't really exist. It's the same as the y value. So there's no hypotenuse. So in this case, if you look at it, sine of theta is equal to, let's see, how would you make this logical? Sine of theta is equal to 5 over 5, which is 1. So secant of theta is equal to 1. Cosine doesn't exist, no value. So that means cosecant doesn't exist, or sorry, secant. It should be cosecant up here. Does not exist. And tan is going to be the opposite over the adjacent. It does not exist. But cotan is equal to 0. So let's see if that's correct. What is the arc sine of 1? 90 degrees, which is where you would find this, 90 degrees. So that's what we're talking about, because it would be up here. To figure it out, really have to consider the radius is 5 along with the opposite, but really just got to remember that cosine of 0 degrees is 1, sine of 90 degrees is 1, cosine of 180 is -1, and sine of 270 is -1. Got to remember your principal points for that. Okay, determine the primary trigonometry ratios for each angle. And this implies that you are going to use your special triangles. So if we look at this, your first step should be always which quadrant is this found in? Now, it helps if you start with your understanding of the unit circle. And it also starts if you start with the main coordinates. 1, 0, 0, 1, 0, -1, and -1, 0. Put that down a bit. There we go. It also helps if you know that the xy coordinates are the same as the cos value, comma, the sine value for that location. This one, because it has a minus, is going in this direction. And because pi over 2 equates to 90 degrees, and you should learn that very quickly. Pi over 2 is 90 degrees, pi is 180, 3 pi over 2 is 270, and 2 pi is 360. It means we're going all the way to 90 degrees here, and this tells me instantly my cos and sine values. Since tangent is sine over cos, we instantly see right now that the cos value for negative pi over 2 is the same as the x value, which is 0. The sine of negative pi over 2 is the same as the y value, which is negative 1. And that tan is equal to sine over cos. Now, since we can't divide by 0, we get null, does not exist. So tan of negative pi over 2 does not exist. Since secant is the same as 1 over cos, and cos is 0, it also is a null value. Since sine is the same, or sorry, since cosecant is the same as 1 over sine, and that's 1 over minus 1, it means the cosecant is minus 1 of always of pi, negative pi over 2. That's what we're talking about. And finally, since cotangent is 1 over tan, you might think that you have no answer, but really remember that tan was negative 1 over 0. Tan was negative 1 over 0, which means cotan is just the flip of that. Negative 1, which means 0. So those are the possible answers. Now to confirm it, try to keep in mind that negative pi over 2 is the same as 270, and I'll just keep it in degrees for simplicity's sake, but you could switch to radians right there if you wanted. And we can just quickly check all our values. So sine is minus 1. I'm just going to put 270 in memory. Cosine should be 0. Tan should be null. Secant should be null. Yeah. Cosecant should be minus 1, yep, and cotangent should be 0. Oh, hang on. So cotangent is saying no value. Let's go back to tangent of 270. Invalid input. That's interesting to me because that should be the same as cos over sine. Cos over sine should be 0. Let's pull up a graph. Try to understand why that is. We're going to put it in, oh, it's already in, it would be negative pi over 2. Yeah. Huh. That's interesting. So let's find negative pi over 2. It's right there. Yeah, it should be 0. Not sure why the calculator is saying no. It's kind of interesting. Let's try it in radians and take pi divided by 2 and make it negative, and then hit cotan. Invalid input. Go to the internet. Huh. That seems to be an interesting little error. Where's the second value? It doesn't matter. I'm almost certain that's correct. I don't know why the calculator is giving it null. Yeah, you can look up that if you want. So odd, very odd. Never really noticed that before. Okay, what about negative pi? Negative pi is simply the other direction. And it's going to be the same value as positive pi. It's the whole point of these values, negative 1 comma 0. Remember that we have x as cos. That means the cos of negative pi is equal to negative 1. The sine of negative pi is equal to 0. And since tangent is sine over cos, tangent of negative pi is 0. Since secant is 1 over cos, 1 over minus 1, and so negative pi is equal to minus 1. Since cosecant is 1 over sine, and 1 sine is 0, we get null. And since cotangent is 1 over tan, which is 0, we get 0. So that's easy enough. Those are easy. Those are right on the 90, 270 mark. Something like this, you have to ask yourself, do we reach pi at all? And yes, 4 pi, or over 4, is simply pi. So that means we're talking about pi plus 3/4 pi. This is the same as pi, or if you want, 4 pi over 4 plus 3 pi over 4. And this is clearly just pi. So if you look carefully, if we go around to pi, we hit 90 degrees as pi. That would be half more. But 3/4 is more than half. So it goes another quarter right there. Well, that's 45. That's 3/15. But if we look carefully, you can say, okay, well, the remaining here is pi over 4. So we're talking about a special triangle. Now, here's the nice thing with the CAS system. We know that cosine and therefore secant are going to be positive. Everything else is negative. So that means I just need to know the special triangle for 45. Well, if you recall your special triangles, 45 was when all the angles, if we made them 1, 1, 1. 45 was sorry, that's the wrong one. 45 was as if you made 1 here and 1 here, and both these corners are 45, which means this here is the square root of 2. And if you look at your SOHCAHTOA, it means the sine of 45, or pi over 2, is opposite over square root of 2, opposite over hypotenuse. The cosine of pi over 2 is opposite, or is adjacent over hypotenuse. The tan is opposite over adjacent, which is 1. We have to adjust based on cast afterwards. Cosecant is 1 over sine, which will just be the square root of 2, which means secant is also square root of 2, and which means cotan is 1 over tan, which is just 1. And that's all for pi over 2. Then we just have to adjust for the quadrant. Well, cosecant and secant will be positive. So, cosine and secant will be positive. So that's the correct answer for this. Not cosecant, sorry, secant. Secant, there we go. But everything else will be negative. So you just slap under sine, you slap a negative. Tan, you slap a negative. Cosecant, you slap a negative. And cotan, you slap a negative. Because we're in quadrant 4, where only cosine and secant are positive. So you just use your special triangle. You find your values. And then you slap the appropriate positive or negative in based on the quadrant you're in. That's why we're learning the CAS system. Okay, what about negative pi over 6? Negative pi over 6 is the same as 30 degrees, but it's going this way. So it's 30 degrees here. So we're really talking about 330. So when you find the sine cosine of this, it's again the same rule. Cosine and secant will be positive, the only ones that are positive. And you have to use your right triangles. Well, for 60, that's how we started with this. We had 60, or if you want, pi over 3 in each corner. And pi over 3. If you divide the top, gets divided into pi over 6. That means we can just focus on the top and figure out the sides. Well, if each side here was 2, when we cut the bottom here, it becomes 1. And we just need to figure out what the tall side is. Well, this squared plus this squared is equal to this squared, which is 4. So that means this is the square root of 3. So I can just use this and then just apply the positive negative signs again. And use your SOHCAHTOA. Well, sine is opposite over hypotenuse. So that's sine of negative pi over 6. But because we're in quadrant 4, it's negative. The opposite is secant, or cosecant of negative pi over 6 is the flip of that. Cosine is the only one that's going to be positive, and that's adjacent over hypotenuse, so square root of 3 over 2. And the secant of that is just the flip of that over square root of 3, and those are the only two that are positive. Tangent is the opposite over the adjacent, but because we're in quadrant 4, it's negative, and cotangent is simply the flip of that, which is negative square root of 3. And that's how you figure it out from the special triangles. You then just adjust for the quadrant that you're in, and that's how it always works. Now keep in mind that technically, we're talking about the same angle as 330. However, negative pi over 6 is really negative 30 because we're going back this way. And that is how it should be written, or as negative pi over 6. Don't make the mistake of saying you figured out 330, because we're really talking about negative 30 or negative pi over 6. It's just the opposite direction. Okay, on to number 4. So the same thing, you want to look at your unit circle and understand where you are in the unit circle in relation to cast. In this case, they just want you to practice the acute angle. 5 over 6 pi is just short of 6 pi over 6, which is 1 pi, which is located at 180. That means 5 over 6 is here, and actually like this, all the way to there. Now, if you look at 5 over 6, and if this is 6 over 6 pi here, the same as pi, if this is 5 over 6, the only thing to get from 5 over 6 to 6 over 6 is pi over 6, which means the acute angle here is pi over 6, or 30 degrees. They're all done like this. So an equivalent expression, I want an equivalent expression in terms of the related acute angle. So since sine is positive here, it's the same as sine of pi over 6, because pi over 6 over here is positive as well, thanks to cast. Now, here's the trick. Cosine, we got to figure out where that is and what sign would go in front of it if it was an acute angle. 5 over 3 is clearly more than 1. It's 3 over 3 plus 2 over 3. So where is it? Well, 3 over 3 is here, as we've determined. This is half more. The 90 degrees is half more. 2/3 is more than half, so that means we're over here. If I look at 5/3 and I look at 2 pi here as a complete circle, 2 pi is the same as 6 pi over 3. That's 2 pi. If this is all the way to 5 pi over 3, so 5 pi over 3, to get to 6 pi over 3 would just be pi over 3. Again, Oh, yeah, that pi over 3 over here that we did, oh, that was pi over 6. That was definitely 30 degrees. Pi over 3 is the same as 60 degrees. But notice in the cast system, this is cosine is positive. The only other place cosine is positive is in the acute angle that we're talking about, so that's fine. We can say that, yes, cosine of 5 pi over 3 is the same as cosine pi over 3. And you can always punch it in your calculator to make sure this is true, even in radians. So you can do 5 times pi divided by 3, and you can click cosine. Remember this value, 0.5. Now we can do pi divided by 3 and hit cosine. And we get the same value. So therefore they are equivalent. Now this one here, pi over 4. Pi over 4 is the same as, going backwards, negative pi over 4 is the same as this way. Since this is pi over 2, and pi over 4 is half of that, we're talking about 45 degrees right here, which means the acute angle we're talking about is still pi over 4. But the problem is, this is cotangent. The only thing that's positive in cosine is, in quadrant 4 is cosine. Therefore, the result of this, whatever it is, would be negative. So keep that in mind. Because the acute angle, which is up here, is pi over 4. But the problem with this acute angle up here is it's in quadrant 1, where everything is positive. Therefore, cotangent of pi over 4 will not be equivalent to negative pi over 4 unless we do this. Cotangent of negative pi over 4 is the equivalent to tangent, negative value, the negative value of tangent of pi over 4. How do we prove this? Again, the calculator. So we're going to put it in radians. We're going to do pi divided by 4. But this time we went negative, right? Oop. We went negative angle. So we have to hit equals and put negative. So that's the angle we're talking about. Now if I hit cotangent of it, remember this value, I get -1. Okay? Now, if I were to hit pi over 4, which is in quadrant 1, and hit cotangent, I'm going to get a, oh, let's make sure that, let's go back. I forgot to make sure. There we go. Negative angle. Cotangent. I forgot to make sure that it's negative. Sure it is. -1. Right? Now let's go and do the quadrant 1 acute angle, which is pi divided by 4. And if we hit tangent, look at that. It comes out positive, which is why we have to make it negative. So by slapping a negative here, we're making these equivalent. We're making them equivalent. So where's this one? 7 over 6 pi. Well, 6 over 6 is 1. 6 over 6 is 1. Which means 7 over 6 is just 1/6 further. We know that pi over 6 here is the same as 30 degrees. And we know we're in quadrant 3, where, according to the cast system, only tangent is positive, which means the result of this will be negative. Well, the secant of this will come out negative, but the secant of pi over 6 will come out positive. So we have to put a negative in front of it to make them equivalent. And again, you can do this by taking 7, making sure you're in radians, 7 times pi divided by 6, and hitting your trigonomic value of secant. And you get a -1.15. Whereas if I do pi divided by 6 in the first quadrant equals secant, it comes out as positive 1.15. So I have to slap a negative in front of it. You can only make them equivalent by determining who is positive and who is negative in which quadrant. who is positive and who is negative in each quadrant, and slapping the appropriate negative sign in front. That's the only way they can be equivalent. And that's what they want you to learn, is how to find equivalents that work. Determine the exact value. I'll do that in a little bit. Okay, as soon as you see the word exact values, it means you've got to pull up your special triangles, but I'm going to just do this value table because I'm going to assume you're pretty good at the triangles. So I'm going to pull up this one. I'd like to have all of them. Let's see if that one's better. No, let's see 45. Let's try this one. Radians, degrees. We'll just use this one and we'll flip them around. Okay, copy image. Oh, that one doesn't have the... There we go. That one's good. Copy image, and we'll just use this as our special values. And when we come across cosecant or secant, we'll just flip the fraction. Again, though, it comes down to where is this in the Cartesian graph on the unit circle. That's your first step. Find this angle. 2/3 is obviously bigger than a half, but less than 1. So since the corners, and it always helps to write these down too, since this is pi over 2, and this is 0, and this is pi over here, and this is 3 pi over 2 over here. We'll just do this. There we go. And this is also 2 pi. We get a good idea of where 2/3 falls. It falls here. Now, if I've gone 2/3 here, it means the acute angle left is pi over 3, because 2/3 plus 1/3 would be equal to pi. So that means I got to find pi over 3 over here. And let's just move this over a bit. There we go. There. Does that work? Pretty much. So pi over 3 is right here, which is same as 60 degrees. And you also have to realize that this is in CAS. Only S is going to be positive. Everything else will be negative. So that means the exact values will be negative for cosine and tangent and secant and cotangent. So here are the exact values. Sine, cosine. So that means for cosine, or sorry, for sine, it's this, positive. And that means for cosecant, it's the flip, 2 over square root of 3. Which means for cosine, it's negative a half, because this quadrant, everything else is negative. Which means for secant, the flip, it's -2, the flip of this fraction. And for tan, it's negative square root of 3. And for cotan, it's just the flip of that, -1 over the square root of 3. And that's all you do each time. Step 1, figure out where this angle is. Step 2, figure out the acute angle by taking this and subtracting that. Or if it was over here, it would be this minus that. And if it was over here, it would be this minus that. Once you figure out the acute angle, consult your table, then figure out CAST and which of these will be positive and negative. And then for the 3 other trigs, just flip the fractions. And that's all you do over and over and over again. Let's see if it's going to be easier doing this. Okay, so we're going to continue. We're going to get rid of this like this. And we're going to look at this one. This one's clearly a bit more than 1. So if I go all the way to here, it's 4 over 4. And then we go 5 over 4 is just a quarter more, which is 45 degrees more than 180. So it's really 225. So that means this is the same as 45 degrees. If we look in this quadrant, the only thing that's positive is going to be tangent. So 45, we're talking about these. which means that sine is going to be negative, cosine is going to be negative, tangent is going to be positive. Cosecant is the flip, negative square root of 2 over 1, so it's a negative. And over 1, no need to write the 1. Cosine, or sorry, secant is going to be negative square root of 2. One of the few times, 45 is one of the few times where cosine and sine are the same. Tangent 1, which means cotangent, is also going to be 1. These are the only ones positive because we're in quadrant 3. Just do that over and over and over again. So if you look at this one, it's 11/6. 12/6 would be all the way around to 2 pi, which means we're 1/6 short, which means the acute angle here is pi over 6, which is 30 degrees. If we look over here, this is in the C area, so only cosine will be positive. So that means the sine is going to be negative, cosine is going to be positive, the tangent is going to be negative. The cosecant is going to be the flip of that, negative square root of 2. The secant is going to be the flip of that, which is 2, positive 2 over square root of 3 because we're in quadrant 4. And the tangent is going to be the flip of that, which is negative square root of 3, or sorry, the cotangent. And there you go. That's how you figure out all those. Okay, continuing. 7 pi over 4 is almost 8 pi over 4. So 8 pi would be over 4 would be all the way around. It would be 2 pi. But we're short a quarter pi. So that means the acute angle that we're talking about is pi over 4. Right in here. So again, we're talking about 45. We're in this area. So that means only cosine is positive. So if only cosine is positive, that means this is going to be the exact, this is going to be negative, and this is going to be negative, which means the cosecant is negative square root of 2. The secant is square root of 2. And the cotangent is negative 1. And there you go. That's how you figure it out for that. Oh, they're only giving me, sorry, they're only asking for the sine. Well, it doesn't matter. It's good practice to do them all. So we figured out the sine. I didn't even notice that, but it's still good practice to do them all. So 5/6 is almost 6/6, which means we're just short of 1 pi, which means we're over here. And it's only 1/6 to go in there. So we're going to do pi over 6 is the acute angle, which is right there, 30 degrees. We're also notice that it's cosecant, which is related to sine, and that sine is positive over here. So that means this is going to be the same as pi over 6, and it's going to be the and it's going to be the positive value of this, but we got to flip it because it's cosecant, not sine, which means we're talking about positive 2 because sine and cosecant are both positive there, and cosecant is the flip of the sine. So there you go. And I could have done all the other ones. It would be negative square root of 3 over 2, negative 1 over square root of 3. It would be, the sine would be a half, positive half. The secant would be negative 2 over square root of 3, and the cotangent would be negative square root of 3. And finally, the last one. If we look at this one, 5 over 3 is past 1. It's 2/3 past. Well, this is a half, so 2/3 is here. So it means we almost went all the way around. But 6 pi over 3 would be all the way around, which means we're pi over 3 short. which means we're doing pi over 3 here, but we have to use the cast system. Only cosine and secant will be positive. Since they want the secant, then that's the only one that's positive, so we have to go to cosine for pi over 3, which is this, and the secant of that is the flip, which is 2. You can always throw it in your calculator to make sure. And just to do them all, we're talking about pi over 3, so sine will be negative square root 3 over 2. It'll be negative 2 over square root of 3 for cosecant. Cosine of this angle is a half. Secant of this angle is 2 over 1. Tangent is negative square root of 3, and cotangent is negative 1 over square root of 3 for this angle, because it's all the same. That's why we're learning the acute angles and the special angles. And you're going to learn how to find even more of those special angles, or exact angles, I should call them. And 6, for each of the following, they're asking us to find it within one period. That's another point, is you can find them endlessly, because you can go circle after circle after circle after circle. So if they give you more than one period, there's a whole bunch of solutions. Determine the radian value. So they want to know what the angle is, essentially. This is sort of the reverse. We still have to go to our special triangles, but this time we want to find it on the table. Now be aware that there's often 2 possible answers here. So be very careful. There's often 2 possible answers. Okay, go to there. If we look at negative a half, and we think about, oh, they want just the cos. They just want cos. So we're going to focus just on cosine. Focus just on cosine. If we look at negative a half, which one has negative half? Well, this has a half. So we have to figure out where cosine is negative. Well, cosine is positive here and here, so therefore we're talking here and here. What value are we talking about? 60 degrees, which is pi over 3, which means the acute angle here is going to be pi over 3 here and pi over 3 here. It's going to be pi over 3 between the line and the x-axis here, and pi over 3 between the line and the x-axis here. The problem is we have to find the acute angle. Well, pi is all the way to here, and then we got to go backwards, pi over 3. So we're talking this acute angle here is 2 pi's over 3. This acute angle here, pi over 3, is a full pi over here, then another third. Well, a full pi is 3 pi over 3 plus another pi, so we're talking 4 pi over 3, which means the 2 acute angles we're talking about are 4 pi over 3 and 2 pi over 3. If we punch those cosine values into the calculator, we will get positive a half, or sorry, negative a half, which is what they want, negative a half. And that is how you figure out the possible angles. Please note, there's almost always 2 possible angles that result in either a negative or a positive, and stuff like this will result in possibly 3. Let's look at, but you use the same method over and over again. Let's look at square root 3 over 2. Where would I find that? Here it is here. And that's with pi over 6, which is 30 degrees. And this time it's positive. So let's go to our cast system. Where's cosine positive? In quadrant 4 and quadrant 1. Here and here, which means I have to find pi over 3 in the acute in the quadrant 1, which is always easy. It's always the exact acute angle. Oh, and it's pi over 6, sorry. And I have to find the pi over 6 here, the acute angle here. But the problem with this acute angle here is that's not the terminal angle. You'd have to go all the way to 2 pi and then subtract pi over 6. So we're talking about 5 pi over 6. Since we're in quadrant 4 and 1, any cosine of this will come out as positive. And again, you can punch it into your calculator and see if the cosine of this and the cosine of that does indeed make a positive result of that. And to figure out the positive result of that, you just take square root of 3 and divide it by 2. And there, we should get 0.866 each time. So let's find out. Let's turn on the radians. Pi divided by 6 equals cosine. We get 0.866. Now let's take 5 times pi divided by 6 and hit the cosine, and we should get the same answer. Oh, hang on. Cosine is more than 5/6. All right, yeah, there's a mistake. So if I taken 2 pi over 6 and subtracted it, I actually get 11. Sorry, 11 pi over 6. I don't know if you caught that. But 2 pi over 6 minus 1/6 is 11 pi over 6 because 2 pi is 12 pi over 6. If I subtract 1/6 pi, I get 11 pi over 6. So it's the calculator helped me spot a mistake. So sometimes if you have time, it's good to check in the calculator. So I have 11 times pi divided by 6. Oh, that's wrong. 11 times pi divided by 6 gets me that. That is wrong. 11 times pi divided by 6. That is not wrong. Sorry. I have to hit cosine, and I should get the same value. Sure enough, positive 0.866666. So that's how you do that one. Let's go on. Where would I find negative square root of 2 over 2? This is tricky. You might say it's not in there at all, except that this value here is an accepted. See, in math, they don't like square roots at the bottom. So what they did is they took this one here, and they said, we don't like square roots at the bottom, so we're going to multiply it top and bottom by square root of 2, which is the same as multiplying 1. Well, square root of 2 times 1 is that, and square root of 2 times square root of 2 is this. So you can see that this here, square root of 2 over 2, is the same as 1 over square root of 2, which is 45-degree angle. Now we're negative here. So where's cosine negative? It's negative in this quadrant and this quadrant. And we're talking about 45-degree angle, pi over 4, which means I go all the way to 1 pi and subtract a quarter. So we're talking 3/4 pi. And I go all the way to this and I add a quarter. So we're talking 5/4 pi. Those are the two angles that if I punch in my calculator, cosine will give me a negative square root 2 over 2, or if you want, negative 1 over square root of 2. Both the same thing. Okay, what about this one? This one you'd also have a hard time finding on your calculator or on your exact value chart, except when you use the same rule. This one is the same as, let's see. No, it's right there. This one. So we're talking about pi over 6. And we're negative again, so we're talking quadrants 2 and 3. Well, pi over 6, if I go all the way to pi minus 6, we're talking 5 pi over 6. And if I go all the way here and add pi over 6, we're talking 7. Sorry about that. 7 pi over 6. So those are the two principal angles that will give you a result in your calculator of negative 3 over 2. What about 0? Well, for this one, we have to go to our memory of where we would find 0 for cosine. Well, in the unit circle, this is 0, this is 1, 0. This is 0, 1. This is minus 1, 0. And this is 0, minus 1. So if I look at that and ask myself, where do I see 0 for cosine? It would be the first value. So I see it up here and down here. The question is, where is this? Oh yeah, okay. So what are these? That's pi over 2, and that's 3 pi over 2. Both will result if I punch in cosine of a 0. And now if I look at minus 1 here, where would I find cosine minus 1? Just there, just once. What is that? That's pi. So cosine of pi is negative 1. Sometimes in the extremes, you only find one answer, whereas the zeros you can find 2. And that's it for number 6.